Hello and welcome friend. In this new video we see the proof of the theorem, first mean value theorem of integration. The statement of this integration, first mean value theorem of integration is, if a function f is a continuous on closed interval a comma b, then there exists a number xi in closed interval a comma b such that integration a to b f dx equal to f of xi into b minus a. Friend, we have seen a theorem, if a function is a continuous then it is integrable. So as here f is a continuous, f is continuous, so it is integrable over the closed interval a comma b. Function is integrable over closed interval a comma b. Since function is integrable, therefore it has, suppose capital M and small m, these are the infimum and supremum, these are the infimum and supremum value of f on this closed interval a comma b. Then we have a relation, we know that m into b minus a is less than equal to integration of f between the limit a to b less than equal to capital M into b minus a. But friend, small m and capital M are the two numbers, and therefore there are many numbers lies between these two numbers, or we have m into b minus a is less than equal to mu into b minus a, as mu is lies between this capital M and small m. We have this capital M into b minus a. Okay. Then you can see that if we compare these two, we get that here integration a to b f dx equal to mu into b minus a. But what is this capital M and small m? Capital M and small m are the supremum and infimum of f. That is, if my function is f of x equal to x square between the limit 1 to 5, then f of 1 is equal to 1, f of 5 equal to 25. So between this 1 to 25 there are number of values. So if we take this 1 and 25, my number is 16, suppose lies between this, then I have a one number f of 4 is equal to 16, which lies between 1 and 5. So 4 lies between 1 and 5. Likewise, if this is the number lies between the supremum and infimum, and f is continuous, it attains its every value between the bounds. That means if this is the graph of this function, this is the supremum value capital M, this is the infimum value capital M, and for all these values, these are the values, this may be any mu. So for suppose there is a mu, then we have one point on this here from x is equal to a to x is equal to here b, x is equal to b lies here. We have that point, we have taken xi such that this f of xi is equal to mu, and we have now f of xi is equal to this is equal to f of xi into b minus a. So integration a to b f dx is equal to f of xi into b minus a. The generalized mean value theorem. If we have two functions f and g over the same interval a comma b, and g has the same sign over this closed interval a comma b, then there exists a number mu lying between the bounds of f such that integration of f into g equal to mu into integration of g over from a to b. So first we take that, let g has positive, g is positive over close interval a comma b, and what is given, f is bounded, f is bounded, Therefore, let small m and capital M be the bounds, that is supremum and infimum, infimum and supremum bounds of f over close interval a comma b. Then small f is less than equal to, small m is less than equal to f of x is less than equal to capital M. Then we can multiply this throughout by g. Therefore, m into g of x less than equal to f of x into g of x is less than equal to capital M into g of x, we can write. And from this we get that m into if we integrate this, m into integration a to b g of x less than equal to integration of f of x into g of x between the limit a to b less than equal to capital M into integration of g of x between the limit a to b. Again friend, what is here, what is given? M is here we are taking this mu lies between capital M and small m. So here we get, if we multiply this number mu into g of x is less than equal to capital M into g of x, and if we integrate this m into integration of g of x between the limit a to b plus mu into integration of g of x between the limit a to b less than equal to capital M into integration of g of x. Now compare these two. If we compare this, mu is a point between this upper bound and lying between bounds, then we have here integration of f of x into g of x between the limit a to b is equal to mu into integration of g of x between the limit a to b.